The lens are, yes, they are made up of glass, but they are not always the same because they are shaped differently.
Sir, I'm so confused. My grandma wears glasses to see far, but my dad wears them to read. How can the same thing do opposite jobs?
Let's observe those and let's see what happens in these different type of lenses. So this is a beam of light. This is an example of concave lens. Light rays are getting far. It is called divergence, and due to that, those people who has myopia, their eye lens converges the light very fast, and that's why they need a diverging lens or a concave lens. Let's give this person a convex lens or converging lens and let's see what happens. See, the concave lens is diverging, making the light rays go far, whereas the convex lens is converging. So let's make an image and see what is actually happening. See here, in this example, there is an object and an image is formed due to the convex lens. So this is the example of convex lens. Now let's understand some of important phenomena. Definition, it's very easy definition, very simple. A transparent medium bounded by two surfaces like curved surface, at least one of which side is curved. Usually we have both side curved lenses. Let's find some important terms. Now optical center. So the central point of a lens is called optical center. Principal axis. So this point, this is like principal axis. Let's say a light ray is passing, parallel light ray, and getting focused at this point. So this will be F, principal focus, and this length from here to here or here to here, focal length. Center of curvature. So let's say this lens is a part of original bigger sphere. It is cut out from there, and that center will be called center of curvature. Usually it's double the distance of principal focus. So usually it will be 2f. So center of curvature is this thing, focal length is this thing, principal focus is this thing. Then aperture. Aperture is usually not in this chapter, but still I will say. Let's say this part is covered for protection and you can only see a small part, means from only a small part the light can pass. From where the light can pass is called aperture, this area where the light is exposed.
Sir, can I also get an image through a lens? Which lens it should be? At present, I don't have a lens, but I want to do these activities. Is there any solution, sir?
Yeah, there is a solution for that. You need convex lens for that. Through a convex lens, you can get an image. See, we are getting an image at different location. You can have an object and you can get its image. Now the solution is you can have a glass of water at your home or a glass ball. If it is transparent, made up of glass, you can fill water and you can observe some similar activities. It's not exactly like lens, but it will help you. Especially the glass bottle or transparent bottle filled with water will show some effect.
Sir, I get so much confused with ray diagrams, sir. The parallel rays, axis, center, focal length, negative, positive, and this and that. Please clarify these, sir.
Very important key concepts, like for example, what is this principal axis, optical center, and stuff like that. Can you see this central line? This central line. This is called principal axis. This is the optical center, and if a ray goes through it, it goes straight without deviation. Let's observe how does it happen. This ray parallel here, it's passing through the focus. Okay, so this point focus, and the ray that's going through the optical center, this one, it's going without any change in the angle. You see here there is no change in the angle, straight line. Now the ray that's passing through the focus before going from the lens over here, see, it's a straight line, then it becomes parallel. Okay, so these things you need to keep in mind, and it's very easy. Even if I move the object, see, I'm going to move the object. Observe this ray, and whether when I change this image, whether it will pass through the focus or not. Just observe that once. So, focus on the focus. See, no matter where I am taking the object, the image is going through the focus. So, it is focused to the focus. Now, in concave lens, if you change the position of the object, much difference do not occur. See, here I am having a concave lens. Now, let us observe this thing, what happens in concave lens. So, first observation, ray parallel to the principal axis appears to come from the focus. Let's find the ray parallel to the principal axis. This ray, it's parallel to the principal axis. After reflection, it's bending like this. Okay, but if you trace it back, it looks like it's coming from the focus. Okay, so this is the observation. See another ray here. Did you observe that after passing through the lens, it's getting parallel? This parallel one got to be like coming from the focus. So, the one which got parallel after the refraction or passing through the lens, when we trace it back and continue, don't you think it will go to the focus? And the easiest one is the last, this ray. It's going straight and it's going straight. So, there is no deflection, it just wants simplicity. So, it will just keep on passing straight. And now, if you observe these rays, it looks like all the rays are intersecting over here or starting from here. So, our virtual image will be here. Now, there will be no real image, you cannot get an image on a screen, it just appears, or technically in a diagram we can say the image could be here, that is it, there is no real image. And since it is virtual, so it is not inverted, but it is erect, number one thing. Number two thing, and quite important for the virtual image, is it will be always smaller and the virtual image will be always between focus and the optical center, that is it. So, let us see, wherever I take, it won't go more than that, it will also be never bigger than original image. So, the diagram for this is easy. If you still have doubt, you can ask in comments.
Yes, sir.
Sir, how to easily understand and remember the different positions of object and image?
Yes, many times student gets confused with that, but if you understand a simple easy thing, there is a very simple small trick. If you observe that, it will be very easy. Observe this. Observe. Object and image both are at 2f, f1, and this is f1, here f2. So, anyway, we do not care for now those things, just to make it simple. For simplicity, I am removing this 2f2 and also f1. Now, observe, at this position, is the object bigger or image small or bigger, something like that? Both are equal, you can see, and one is upward, another is the image is downward, means vertically opposite. Now, let us change the position and see what is happening. The far the object is going, you see the image is coming closer, the closer the image is coming. Okay. So, it is diminishing, means when object is more than 2f, the image will be between f and 2f. When the object is 2f, the image is at 2f2. Now, beyond 2f, the image also will be between f2 and 2f2. When the object is beyond 2f, this one image is in between, this is 2f2. So, see, I am bringing it closer and let us get it closer and closer. Will it go beyond this point, beyond this 2f2? Let us observe. And will it become bigger? See, it is getting beyond and it is getting larger. So, here it is magnified or enlarged. So, this one we observed just now. Real inverted, enlarged, that is inverted, upside down, that is a real and inverted. Real means all images we can get. If we put a screen over here, we will get this image. And let us do that. Let us put a screen and let us see the image. Here we are getting real image. Now, let us have a virtual image, means fake image. This is a fake image. This does not exist. Virtual. And it will happen when it comes more closer than focus. Now what will happen if I take the object even to the focus? So let's see at f1, see the image. Are you getting an image at all? No image. Okay, so there is no image, but we can still say the position. It's going to infinity. That's why position is infinity. So in new books also it's revised. Earlier it used to be said that there will be an image in infinity, but since nobody can go at infinity and obtain an image with a screen, so now they revised it to no image. So in this position at f of the object, the position of the image is infinity. Here it will come as no image. So that's a new difference you need to keep in mind. Let's take the object even further, closer to the lens, and what will happen? Will it go further or something else will happen? So see, observe what is happening to the image. See here, this position, see this position. So here we are getting image, but actually we won't get it. It's a virtual image, means just imaginary. Larger, highly enlarged actually. Yes, that's it. And also it will be erect, means straight. It won't be upside down. Concave lens is very easy. There is only one condition, always diminish between origin and f. That's it. See, this is the object and this is the image. There is only one condition. It will be diminished and virtual. Position will be this position. This is f and this is o. So origin. So position is between o and f always, and the size will be diminished and it will be erect. That's it. So now sign convention. Observe, it's also very easy. Upward will always be positive. That's it. Here also upward will be always positive. Left from here, from origin, left this distance will be always negative, and right from the origin again will always positive. Similarly, from 0 downward will be always negative. Here also negative. And distance always will be measured from origin 0. That's it. In the exam, in the numerical, sometimes there will be given as the focal length is minus 2 centimeter or plus 10 centimeter. Minus plus, how you will understand it's a concave lens or convex lens? So keep in mind, if the focal length is plus, like plus 2, this one, which one lens is this? Convex lens. So always if focal length is plus, f is positive, then it's convex, and if it's negative then it will be opposite, concave lens. So if focal length is given negative, minus 2, minus 3, if f is negative then it's concave lens. And what it does, it makes a virtual image and also makes it diminished, whereas the convex lens can enlarge it, magnify it. You can take a screenshot.
Yes, sir.
Some important formulas. So let's go through that. So lens formula, 1 by f equal to 1 by v minus 1 by u. F is the focal length, v is the image distance, u is the object distance. Magnification is also very easy, m equal to v by u or h dash by h. This h dash is for image height. So it's not hard, but yes, you must practice, then only you'll get it. So one more thing, observe, magnification formula for lens, there is no negative sign, whereas in the focal length 1 by f equal to 1 by v minus 1 by u, there is a negative sign. That's the difference.
Sir, my friend uses minus power glasses, but I don't understand what that means. I feel like I'm missing something huge here.
Now power of lens is very simple, P equal to 1 by f, that's it. Now keep in mind f should be into meters. So let's say if someone has minus 1 as a power, so like let's say someone specs got minus 1d, and now let's find which glass is that. So for minus 1d let's put the value over here in this formula, minus 1 equal to 1 by f. So just a cross multiplication, and we have, like, let's take f that side and minus 1 this side. We get f equal to minus 1, or just 1 by minus 1, that will give us minus 1. Okay, now keep in mind it was in meter, so let's convert into centimeter, and it will become f equal to minus 100 centimeter. So your student, so your friend, if she is using minus powered glasses or specs which has negative power, it means she is using a concave lens, easy peasy. And it means she has the defect of myopia, that will come into the human eye and colorful world chapter. So myopia does make the object too much enlarged and focus before the retina itself, and for that, to adjust that thing, we need to put a concave lens. Similarly, if the power is positive, means it's a convex lens, easy. Now uses, there are these uses, it's used in camera, lens is used in camera, microscope, telescope, human eye, like we don't use, naturally it's there in the eyes, so that one, magnifying glass, specs, yeah. Concave lens used for myopia, camera viewfinders and optical instruments. So here is the table for the important formulas. All the formulas revised over here, mirror formula, lens formula.
By the way friends, if you forget to subscribe B.E.S.T Classes channel, then you can search on YouTube at bestclasses.pandey sir. Till the next time, Bharat Mata Ki Jai and best of study. And don't forget the famous phrase of Pandey sir, push past your limits.